morning, mathematicians. Today we are going to be using our definition of sine and cosine in order to evaluate different inputs. So if we look at our do now here, sorry, I had to fix my camera. I'm asking you to basically determine what sine of beta is in simplest form. So I know that the terminal ray of beta, that's a Greek letter right there, B represents beta, lies in the fourth quadrant, and cosine beta is equal to square root of 2 divided by 3. Determine sine of beta in simplest form. So over here I just transferred like what I knew about this problem here. And since it's asking me about sine of beta, and I know what cosine is, I should be thinking of that trig identity that we talked about last week, that said sine of theta squared plus cosine of theta squared is equal to 1. Remember, we just got this from our unit circle there. The equation that we formed for our unit circle was x squared plus y squared equals 1. And the 1 came from our radius of the unit circle. I could change theta here in this scenario and write it with a beta. It still means the same exact formula there. So in this case, I know that cosine of beta is equal to the square root of 2 over 3. So I'm going to replace that with the square root of 2 over 3. And I'm just going to rewrite everything else in my equation. And then this is what we did last week. So at this point, it's a straightforward calculator question. I need to do my order of operations, which means I need to take the square root of 2 divided by 3 and square it. Remember, if you're using a calculator, to make sure you're using parentheses. And math enter will help make it into a fraction. So I took the square root of 2 divided by 3 and I squared it. Math enter, that transforms that into 2 over 9. What a nice, beautiful ratio. And I still have sine beta squared there. Now remember, this is just like if I said to you in Algebra 1, hey, solve for x. So what I need to do is I need to move everything else away from here. So my first step in this problem, well, I guess the second step, is going to be to subtract 2 over 9 from both sides of my equation here. What I do to one side, I must do to the other. And then those are going to cancel out, leaving you with sine beta squared equals, and again, straightforward calculator question, 1 minus 2 divided by 9. Notice I put parentheses around my ratio. You absolutely have to. Math, enter. I get 7 over 9. But I'm not done yet because this is saying sine beta squared, and our directions simply asked us to find sine of beta. So my last step here is to take the square root of both sides. Now, when I said to you guys last week to express your answer in simplest radical form, you can simplify that further. This is really saying to you that sine beta is equal to the square root of 7 divided by the square root of 9. Both of those values are underneath the square root. The square root of 7, I unfortunately cannot do anything with, but I know for for the square root of 9, I can reduce that to 3. So my final answer here is the square root of 7 divided by 3. But again, there is some very important information here, and that's telling you that it lies in the fourth quadrant. So now I need to think of my unit circle, and in my fourth quadrant, what do I know about my x and y values? So I know here that Jan Korn would tell us our x value is positive and our y value is negative. So I need to apply that concept to this example here. And in order to do that, I need to think of like what is sine actually representing, which value, my x or y. And Lyra would tell us that that's representing our y value. So since it's our y value, I know that it needs to be negative, which just means that you need to put a negative in front of your answer there. So sine beta is equal to negative square root of 7 divided by 3. And that's that. When I'm saying explain your answer, I want you to tell me why we had to put a negative there. Is that always going to be the case every time you solve it? How do we know that? Okay. All right. Today, moving right along, that was all old news, a little refresher for you. We are going to continue evaluating our trig expressions. But we're going to be using different angles from our unit circle to help us there. And we're going to be given a function. So notice here I'm giving the function f of x equals 6 sine of x. And I want you to evaluate each of those. So remember when I say f of x, that's a fancy way of saying y equals. And when I'm saying 6 sine x, that's basically saying 6 times sine x. Remember, they don't put the dot because it's just understood that you knew they were multiplying. Just like if I gave you a function and wrote f of x equals 3x squared, you know that you're multiplying 3 by that x squared. Or if I wrote 3x, you're multiplying 3 by that x. They never put a dot there. They don't put parentheses. You guys are past that knowledge. So you need to understand that since there is no symbol in between those two terms here, the 6 and the sine, that means that you are multiplying them. So A, I'm asking you to evaluate f of 30 degrees. Well, this is tying together all of our units. Think about what it meant when I have that 30 degrees inside my parenthesis there. This is function notation. So you should be telling me, poet, that means that x is equal to 30. And since x is equal to 30, that totally allows me to go ahead and replace x in my function up there. So Danny might rewrite his paper as 6 sine 30. He took out the x value and plugged in the input, which is absolutely perfect. And now it comes down to, like, how do I simplify this? What do I do in order to get my answer here? Well, I'm going to focus in on sine 30 right there. What is sine 30 actually equal to? So this is like really applying all of our concepts here. Sine 30, oh, that means that I'm looking at my y value at 30 degrees. That's basically what that's saying to you. Remember, sine means my y value, and I have my 30 degrees plugged in there. So I want to look at my unit circle and see, like, okay, what actually is my y value at 30 degrees? 30 degrees, I have square root of 3 over 2, comma 1/2. That means the 1/2 should be substituted in. So that entire thing right there is equal to 1/2. And I'm just bringing down the 6 because I didn't do anything with that value yet. And your last and final step is going to be 6 times 1/2, which will give you a final answer of 3. So that's it. F of 30 is equal to 3. This is like what you guys did at the very start of the year in like November, when I gave you quadratic functions, when I gave you rational functions. You took a value, you substituted it in for x, and you just simplified it using your order of operations. So let's look at B. B is saying to you B is saying to you f of 45 degrees. I'm using my same exact function here. So 6 times sine of x. So my first step here is, well, what does the 45 degrees inside my parenthesis there mean? So Omar would tell us that means that x is equal to 45 degrees. So I'm going to substitute that into my function, which Alice would write something like 6 times sine of 45 degrees. And this is not your final answer. You can absolutely simplify that further. So I'm just going to focus in on what is sine of 45 equal to. Well, again, that's basically saying to you, as Ruby would mention, that's your y value at 45 degrees. So if I said, Lynn, what is the y value at 45 degrees? She would tell me that it is the square root of 2 divided by 2. Okay? And again, you're not done. You absolutely can simplify this further. So it comes down to, well, how do I simplify that further? You can make this 6 into a ratio and just straightforward multiply your values. So I'm going to multiply my numerators together, which would give me 6 square root of 2. 2 times 1 would just give you 2. These are not like terms, so that 6 just came right along right in front. And my last step would be, can I simplify this further? Well, absolutely. 6 divided by 2, that's going to give me 3 square root of 2. And that's your final answer there. Okay? So today's lesson is all about playing around with the trig functions. Okay? I have a bunch of different examples here for you to practice. Good luck. Have fun. I'm going to leave you with C and D. I'm going to leave you with this example. Do not be worried because there's 2 trig functions in there. A nice little plickers. This is a review from yesterday and another one to evaluate. Have fun. I will schedule a Google Hangout for Wednesday. And you guys got this. Let me know if you have questions.